Let's look at this question. Okay, this question we're going to verify whether the circle is touched internally or externally, right? So before that, we also want to show that does the circle touch or not? All right. First, so by observing the center, all right, we can identify whether the two circle is touched or not, or internally or externally by observing the distance between the two center. So for example, for circle number 1, right, I label circle number 1 as C1. Okay, for C1 we can getting the center, right? We can getting the center, as you know that the equation of circle, the standard equation will be x minus h square plus with y minus k square equals to r square, right? So based on this, we know the center, and we can know the radius from the value here. So for example, these cases here, we can know the center as this will be your h and k, right? Negative 1 will become positive 1, 1. And the radius for this circle will be 3, as this is r square, 3 square, right? So based on that standard equation formula, we know that the radius here will be 3. This is for center. For the first circle. Okay, let's look at the second circle. So x minus 5 square plus with y minus 4 square equals to 4, as 4 can rewrite as the 2 to the power of 2, right? So and the center for circle 2, all right, let's label this to be center for circle 1 and center for circle 2. So this will be negative 5 will become 5 and negative 4 will become 4, right? And the radius for circle number 2, all right, the radius for circle number 2 will be 2, right? 2. So whether this two circle is intersecting or not, we can observe the center between the two circle, right? So for easy to say, you look at the distance, right? The distance between C1 and C2. Okay, the distance between center 1 and center 2. So you can actually find the distance between these two center. All right. By observing the distance between the center, you can know whether the circle is touched or not touched. So let's explain some concept first. So if two circles are touched externally, so means this is called touch externally, right? Let's say that you have a center 1 and center 2. This is for your knowledge so that you know. So if two circle is touched externally, this is externally. Alright, so then we can say that the distance between the two center, the C1 and C2, is the same as the sum, because from here they will form a line, right? Because they are touch, so they touch at the common point here. So it means that there is a tangent here, right? Common tangent. So here will be 90 degrees. So they were forming a straight line, right? A straight line between C1 and C2. So, and we can say that this will be the radius for circle 1 and this will be the radius for the circle 2. So if this two circle is touched externally, we can say that the distance between C1 C2 is R1 plus R2, the radius 1 plus with radius 2. So very simple as that. So once you verify that the distance between the two center is the sum of the radius, means that they are exactly the same, this is very sure that this two circle is actually touched externally, right? Okay, let's look at internally. Before we doing this question, so I explain some concept first. Alright, what happens if the circle is touched internally? Let's say you have a circle, then you have another circle, they are intersecting but they are actually touch each other. Alright, so then of course this will be, we have two center, right? We have two center. So one is the center for the first circle, right? The bigger circle, and another is the center for the smaller circle. So I label, let's say I label this to be C1 and this to be C2, right? Label C1 and C2. So of course they will have a common tangent, right? Okay, I should draw properly. So they will have a common tangent where this line will touch here at 90 degree, right? 90 degree. So, alright, so I have to draw carefully. So as these two will be intersecting at a point, and this will be, there is a common tangent between these two circles, right? Because they touch internally. So what can I say about the radius, right? The radius here. So then I observe the distance. Always find the distance between the two circles. So the distance between the two circles will be always equals to when they are touched, right? So means you look at the C1, the radius from the center for the bigger circle. So I label, this will be the center, right? Center. So center to this point of contact here, where they touch. Okay, these two circles touch at this point. So this is the radius R1, right? The radius R1. The distance here will be radius R1. And this circle, the second circle, all right, the smaller circle, will be the radius will be from the center to this point also. This will be R2, right? So what can I say about the distance between these two, right? Between these two centers? It's the same as you take the R1 minus R2. R1 minus R2. As long as you can verify that the distance between the two circles, is the difference between of the bigger radius, the difference between the radius of the bigger circle minus with the smaller circle is the same, exactly the same. The distance between these two and this, the radius 1 and radius 2, you minus, you're getting exactly the same. Means that these two circles is touched internally. Alright, is the two circles C1 and C2 are touched internally. Alright, this is for your knowledge to verify that two circles is touched externally or internally, right? So very important, you try to replay the video and look at this concept here. Alright, so now let's apply to this question here. Let's see whether they touch internally or externally. Alright, okay, let's look at this question here. So we have two circles, right? Two circles. So at first we find the distance between the two centers first, right? To find the distance between the two centers, you know the formula, right? The distance between 2 points, right? We're using the formula. So the distance between C1 and C2 or C2 and C1 is the same. So 5 minus 1 square, right? 5 minus 1 square plus with 4 minus 1 square, right? So you will have, for this you will have 4 square, 16, right? And this you will have 9, 3 square. So you're getting square root of 25, which giving you the value of 5, right? Means the distance between the two circles is 5, right? Okay, let's see whether the sum of this is 2 or not. Okay, let's apply R1, okay, plus with R2, R1 plus with R2. So R1 plus with R2, so you look at this, if you take R1 plus with R2, okay, R1 plus the distance, all right, 3 plus 2, okay, 3 plus 2, so you were getting 5, right? Can you see that? They are exactly the same, right? The radius, the sum of the radius and the distance between the two centers have the same value, which is 5 and 5. So I can say that these two circles is actually touched externally. Alright, they are touching externally. Where the I can say that these two circles, okay, with the radius of 5, 4, and the circle with the radius of 1, 1, they are actually touched externally. As long as you can verify that C1, the distance between is the sum of the R1 plus R2, then they are touched externally, because the distance between C1 and C2, alright, C1 and C2, so must be the R1 plus with R2, right? R1 plus with R2, so means they touch externally. So okay, let's go for next example. Right, okay, let's look at these examples. Okay, this is another equation of circle. X minus 2 square, y minus 1 square equals to 5, and x minus 4 square, y minus 5 square equals to 45. So does these two circles touch internally or externally, right? This question actually already telling you they are actually touch each other, these two circles, but either they are touched internally or externally. So to verify this very easy. So for center one, the first circle, okay, this one is C1, let's say this to be C2. So the first circle, the center will be 2, 1, right? And the radius, of course, if you come, this is R square, so you're getting square root of 5, right? So this is R square, so R will be square root of 5. And for center 2, we have 4 and 5. And of course, the radius will be square root of 45, right? Square root of 45. You can simplify this by writing as 9 multiplied 5. So you are getting 3 square root of 5, right? It's a third. So, alright, to verify whether they are touched. So if they touch internally, okay, touch externally. If they touch externally, the result will be the distance between the two circles is the same as the sum of the two radius, right? So when they touch internally, so just now I have shown you the diagram. Internally, the distance between the two circles will be the same as the difference of the distance between the two radius, right? Means that the radius, the radius of the bigger circle minus the radius of the smaller circle, they have exactly the same as the distance between the two center. So then we said that this is touch internally, right? You can replay back the video to try to see the diagram. Very important. So let's find the center between the distance between these two center here. Alright, let's take square root of 4 minus 2 square plus with 5 minus 1 square. So we just calculate, and this will be 2 square, right? 2 square plus with 5 minus 1, we have 4 square. So we're getting 16 plus 4, we have 20. Simplify this, we can get right in the form of third. Simplify the third, right? This is a third. So 4 times 5, square root of 4, you're getting 2 square root of 5, right? Okay, let's look at this. The distance between the two center is 2 square root of 5. Okay, let's see which circle is bigger, right? Which circle is actually bigger, right? Of course, you see the radius here will be bigger. It's longer, right? It's longer compared to this, so this will be bigger. So I take the radius of the second circle, right? Of the second circle minus, as long as you take the big one minus the small one, okay? Minus the small one. So you were getting 3 square root of 5 minus with square root of 5. It happened to be 3 minus 1, you're getting 2 square root of 5. Can you see that? The distance between the two circles, the center, okay, the distance between the two center of the circle is the same. You see, the value is the same. So the distance between the two circle is the same as the difference of the length of the difference of the radius of both circle, right? So the exact once you show that these two are the same, right? These two are the same, so means that the circle is touched internally, alright? This is a way we verify, okay, whether two circle is touched internally or externally, alright? I hope you understand, and this is always true, alright? You try to think about this diagrammatically, alright? I think that's all for this video.